Hi, everyone. Welcome to the Hackaday Prize award ceremony. I'm going to actually take this out. I'm Sophie Kravitz. This is Mike Stish. At the end of this ceremony, we're going to crown 5 winners, and the grand prize winner is going to win $150,000 and a residency at the Supplyframe Design Lab, which is where the next door facility that you've all been in today. The Hackaday Prize was started in 2014 by Supplyframe's CEO, Steve Flagg, who wanted to encourage social change through hardware, coding, design, and other generally smart projects. Now it's in our 3rd year, and the Hackaday Prize is synonymous with creating social change.
We have a great amount of fun making these videos, but we spend a lot of extra nights and weekends and a lot of sweat and a lot of tears doing it because we think it matters. That's really the point of the Hackaday Prize, is to get people to unlock their skills and really build something that matters, to do something that inspires people, to lead to meaningful change and positive change in the world. And we've been really successful and really lucky with that. When we started thinking about the Hackaday Prize for 2016, we wanted to pull in as many people from as many different skill sets as possible. So we actually divided it up into 5 different challenges. The first challenge was a design your concept challenge. So show us how you can take an idea and fill it out through to an entire plan. And we took 20 winners from the first round and awarded them $1,000 with the hope that they would take that idea, that concept, and actually build it into a full project, a full prototype, a full proof of concept. And we saw that from almost every one of those finalists, whether they made it through to the final 10 or not. They put a lot of blood, sweat, and tears into their own projects. The other 3 rounds that we looked at were anything goes, so build anything that you want, citizen science, the automation, and assistive technologies. Let's look at one of the videos and see what the judges have to say about 3 of our top 10 finalists.
Low-cost, open-source industrial servo motor. Mechaduino features a 14-bit magnetic encoder for precision position feedback. True closed-loop control rejects disturbances. In addition to closed-loop position control, Mechaduino features velocity, torque, and user-definable modes.
I love closed-loop control systems, and I can still remember the first time I built some kind of closed-loop, thing. It was like a DIY laser projector, and so I was using the hard disk voice coils and some little optical sensors to provide feedback. And the first time I had a piece of code which was acting like a spring, and I could kind of push on it and feel the force response, and actually have this physical system which was responding to this equation that I typed in to an IDE somewhere. That was a really cool experience, and it just requires so many steps because it's not just, blinking an LED. It's having inputs and outputs and a loop, and it has to be fast enough. And it's really easy to break the hardware if your control loop isn't working properly when you first test it. So it's this whole sequence of things, any one of which could cause you to kind of want to give up. And so it's really great to see a project come out and hit what I think might be a sweet spot between, having something that's easy to use, but also really powerful and isn't going to break the bank, because I think they've taken a pretty novel approach to reuse readily available components to make a really nice product.
And sometimes I think people can easily dismiss simplicity, like, it's just it's like an Arduino with like a stepper motor controller on it, and it can't even do other stuff. Sometimes you have to just execute simplicity well to make sure that it's usable for lots of different people.
The FlyPy itself is another, it's an automated science platform wrapped around microscopy, right? If I'm saying microscopy, right? Microscope. I want to say microscope. But anyway, so it's all about automating the science. And so it has like a light source interface. It's got motion control if you need to change your aspect. And it's got logging capability as well. So you can get, you can take like a series of readings and measurements over a period of time.
So what I like about FlyPy is that they give you some tools for setup, and you can choose which tools you want to build into your project. And it's sort of modular, that you can add the parts that you're interested in and not the parts that you might not need, or you can build on what you have. And the idea that you can do it all low cost wherever you are with the tools that you have on hand.
But also they've gone the extra mile to say, the experimental setup part, and I don't know how else you'd describe that better, but essentially they've got specific experiments they can do with the setup. So to do with the wavelength and frequency of the light, they've got specific tests to look for specific parasites and do various other scientific testing. So I thought that was quite, taking the USB webcam microscope thing to the next level and actually saying it's applied to these things and situations, the developing world, and so on.
Dextra is an open source and low-cost myoelectric hand prosthesis. One of the key features of Dextra is its size, which is the size of an average male hand. I really wanted to make it compact, with all the actuators and electronics embedded inside the hand, so that any amputee with any level of amputation could use it. The key to the compact size of Dextra is its design based on finger modules. Each module comprises a micro-geared DC motor, position feedback provided by a magnetic encoder, and the mechanical printable finger.
I was really impressed by this hand, particularly because of the ability for it to have a dexterity to pick up many different things. The videos, well-documented videos showing the ability of this to pick up squishy things and hard things, yet doing it on a well-documented but really low-cost system. It's probably dating myself, but when I was learning grass maps and in robotics classes 15 years ago, these systems were really complicated and really expensive. To be able to pick something up with the precision and the reliability that they're showing in this video. So the fact that someone could actually take these instructions and go and build this, it was pretty shocking to me.
And in the video, you can see the creator putting the whole thing together, in time lapse, but still 26 minutes to put the whole hand together. And I also like the fact that there's force feedback, or at least motion feedback control. So if you grip something, the hand knows that it's gripped down. And I think that's actually a new feature that I hadn't seen in sort of DIY prosthetics before.
All right, so some amazing of the top 10 right there. We've actually built up a legacy with the Hackaday Prize in the few short years that we've been doing it. So our grand prize winner, the Hackaday Prize winner from 2014 was SatNogs. They designed a satellite tracking antenna that could automatically track objects as they go through the sky, but then built the underpinnings of internet framework so that you can schedule time on other people's satellite trackers in their backyards and thereby track satellite going around the world. And of course, the important thing for this is it unlocks personal satellites. So you could have your own CubeSat, or university could have your own CubeSat going around the Earth. But if you only have one antenna, you can only track it when it's overhead. This network allows other people to build them and allows you to do time sharing with them to track as it goes around the Earth. But since they've won, they actually formed a foundation called the Libre Space Foundation. And this year, that foundation has published the first open hardware specification for a satellite. They've assembled the first space-ready satellite, and it's been delivered. It's awaiting transport up to the International Space Station and will be launched later this year. The winners of the 2015 Hackaday Prize were iDrive-O-Matic, and this was a group of 3 builders. 2 of them are living with ALS, and they were in a situation where people like them maybe weren't able to navigate by themselves. They have eye gaze control, which allows them to use a computer with their eyes, but it wasn't connected to the mobility of their wheelchairs. And their team came up with a design that is kind of like universal. It can go on any chair. It straps over the joystick interface, and it doesn't obscure it, so it can still be used by caregivers, but it allows them the ability to move on their own. And this year, that has actually gone into production and is being sold. Let's take a look at the next set of finalists.
Commercial optics holders are expensive, so I made a holder and ring system using a laser cutter and some common hardware. The holes are threaded to take cap head screws, and these stick to magnets in the rings. This works pretty well. You can adjust the aim up, down, and left, right, and the ring doesn't slide around or fall off. You can put magnets in the holders for better stability, but most of the time these aren't needed. The kit lets you examine and prototype all the common optics functions such as projection, magnification, and even advanced laser effects, such as the Michelson interferometer shown here.
So the gist of this project is instructions and files to create your own optics bench using a laser cutter. So trying to make some sort of high-end experiments fairly accessible to anyone who has a laser cutter. For me, what was really neat about this project is that it's incredibly well documented. It was easy to read, all very well photo documented. But a lot of effort was put by this team to show their full process and the pros and cons. It left me wanting to run over to my laser cutter and make an optics bench, which wasn't something that I really ever had on my to-do list, which is sort of a neat thing for a project to leave the website thinking, oh, now I kind of need this. Like, I have those tools. I can make this. So the neat thing is I think a lot of classrooms that wouldn't normally think about this, and when I say classrooms, I mean it loosely. I mean, this could be your makerspace, this could be a college classroom, this could be something that you're doing maybe with a high school physics class. Really acknowledging that this is typically a pretty pricey set of tools. And the prices that this project are quoting really do come in under $100 to create this.
We introduced Facade, a crowdsourced fabrication pipeline to help blind people independently make physical interfaces accessible. Blind users capture a photo of the inaccessible interface with a dollar bill for absolute measurements. These labels are then used to generate a 3D model for a layer of tactile and pressable buttons that fits over the original controls. The printed overlay is designed to be easily aligned and attached to its appliance using adhesives.
So basically, it's to help people who are blind or partially sighted generate tactile interfaces for appliances by themselves, which I thought was a really good innovation. So essentially, you stick a dollar bill on the next to your, say, microwave keypad was the example, or anything, and you scan it with an iPhone app, and it goes off, and it's crowdsourced for people to suggest what that interface should look like as Braille or as other symbols. and it basically generates, using open source software as well, they're using OpenSCAD or a variant of it with, I believe, a JavaScript plugin or something to actually dynamically generate a 3D model that you can 3D print and then stick on that interface, and then you can obviously feel it to use it. And it's so that basically the person who can't see, as long as they can hold their phone and they know roughly where the appliance is, they effectively can get this thing generated by themselves.
I think one of the things that's going to make it really cool is that they're going to develop a library of created interfaces for specific appliances that people can just download and print.
Box0 is easy to use. Just plug it in the USB port of your smartphone or computer, launch the software, and your workbench is ready. Box0 provides affordable access to an oscilloscope, signal generator, power supply, spectrum analyzer, sensor interface, real-time data logger, and many other tools.
There's a lot of ways in which you can now replace what used to be a really expensive tool like an oscilloscope. Like you have similar processing power available now on inexpensive microcontrollers, right? But those aren't necessarily products that Agilent or HP or Tektronix are rolling out. Like they're still making like high-end stuff. And so there's like a real gap there, I think, to be able in a low-cost platform to provide like a lot of kind of introductory tools.
I teach controls lab courses as an engineering professor, and our equipment is ridiculously overpriced. And we're running into constraints with number of students that we just can physically put into a lab situation. So if I can say, buy this open source hardware widget and plug it into your phone and do the lab remotely, I think it would have benefits in more than one way, because students get to learn on their own time in that way and not just kind of a 2-hour lab, fake hands-on setting.
Hold an object at an angle to the light, tilting it back and forth to see subtle surface details you can't see when you're looking straight at it. You're taking advantage of the way the light interacts with those surface details to make them more easily visible. Reflectance transformation imaging, RTI for short, is a digital version of this technique. Photos are then processed in software to create a virtual lighting model, so that using the viewer, you can set the lighting angle to any desired position to reveal details in the object. With my design, up to 64 LEDs are installed on the inside of a plastic dome. The system supports automated triggering of the camera's shutter in synchronization with the LEDs for many different makes of cameras.
So this project, I was so taken. I've never really thought about pictures in museums and how to get these detailed images. And seeing the photographs was really exciting. I could see, I just got back from a weekend of camping. I could see having a lot of fun, looking at rocks differently using a device like this. This is a neat project that now opens it up to a lot of other citizen science and art applications.
So, this seems like a really good application of the technology that's already out there, and there's some stuff out there that you can combine in a novel way and add some software, and now it does something really amazing. And even more so, I see this as being, a unique offering from the kind of open source world, because you wouldn't really see this from industry, and if you did, it would be astronomically expensive. It wouldn't be accessible to everyone. So I feel like this is one of those projects that is both kind of intellectually and practically interesting, and is just really well executed.
Just a word about our sponsors. We had 4 this year: DigiKey, Microchip, Atmel, and our parent company, Supplyframe, all believed in that this kind of competition could create social change. So we want to say thank you and do a round of applause for our sponsors. So let's take a look at what our judges thought of the last 3 of the 10 finalists.
How do you teach a 5-year-old to play the harmonica? Well, at my kindergarten, we use a big poster on the wall that looks something like this. And the teacher points to a square and says, do, re, mi, There's got to be a better way. So I came up with this. The classroom music teaching aid. Something to help kids learn how to play the harmonica. Let's turn it on and see what happens.
So I like this project a lot because it started with a really focused problem. And so, sometimes you have a project and it's sort of trying to solve everything all at once, but this is a really focused problem, and therefore you can have a really focused solution that really solves it really well. So in this project, the creator made a music teaching machine that solves a problem that's pretty common, right? Like, how do you explain to someone how to play a music instrument? Other than just by random trial and error making sounds with the instrument, this would give the student instant feedback of how what note they're playing.
You can have one display that reminds the kid that the note that they're playing is the same one that the teacher was playing, or if they're different, lets them see what the difference is. And I like this sort of almost prosthetic synesthesia, where you can have these devices that give you these extra connections between senses. So if you maybe wouldn't quite have made that leap on your own, but you can see that via the kind of technological prop, then that can help you reach additional leaps that maybe you would make after that.
I'm Aaron Molnar from Hungary, and in this video I'm going to present you my new invention, the ferrofluid core differential tilt measurement sensor.
LVDT stands for Linear Variable Differential Transformer. An LVDT has 3 coils, 2 secondary and 1 primary, and the primary coil is usually excited with an alternating current. So depending on the movable iron core's position, different voltages are being induced in the secondary coils.
You would probably heard about what ferrofluid is. It's basically function like a liquid metal. So if we change an LVDT's iron core to a cell, half filled with ferrofluid, if we tilt or accelerate the sensor, the amount of ferrofluid in a secondary core is changing.
It's really nice to see people developing brand new sensor technology. In fact, I don't think of all the contest entries that I judged, I don't think I actually saw another sort of basic fundamental sensor tech like this before, which made it pretty unique. In addition to its actual design, and so this is a linear variable differential transformer that uses a liquid as its core instead of a piece of iron or something like that. It's really quite an ingenious idea. It's simple and it's very effective in what it does.
I thought that was so cool. For one thing, ferrofluids are awesome, but pretty useless for the most part. I mean, it's goopy and messy and gross, right? And hard to work with. And he's actually using it for something useful, which is really cool. I liked watching the progress of the project, that they talked about why they were starting it, and then went all the way through publishing the abstract for the paper that they have under review. So I really enjoyed that.
This is Tito. It doesn't look like much, but when it links up with the rest of its pulse, things get a little bit more interesting.
So I initially thought this is a robot that you can snap the blocks together, and out of it you build a little snake. But what I saw was it had all kinds of other potential locomotion methods that I hadn't even thought of. Crossing a little bridge, for example, or turning from a snake into a wheel. And these are really neat, trying to figure out ways to get to places that robots otherwise can't. I really thought I could also follow along the set of build instructions and easily build one of these things. I can imagine going to meet up with mine and meeting up with people who have 20 others, and we connect them together and make super robots.
And the thing about Ditto that's so cool is, number one, it's like not a multi-million-dollar research lab that did it, and two, just all of it's clear that they just run that robot all the time. The number of different things that those modules are doing in the videos, like they have them sliding down inclines, climbing up stairs, like detaching and reattaching, or like figuring out how they can go up or down. And in our research group, when people make the robots, it's like, they're really excited when it works once and they make a video of it and then they write a paper about it, it's kind of over, And this Ditto robot, it seems like they're just kind of like goofing off and trying to figure out and learn how to do different things with the robot.
some truly amazing top 10 finalists. So I loved those videos, and the best part of those videos was hearing what the judges had to say. We're really fortunate when you put on a huge engineering initiative like this and you specifically target a bunch of different themes, you need a bunch of different experts. And we reached out to the community that kind of surrounds Hackaday, and we had overwhelming response from these judges, 14 of them who donated their time and their talents, not just to judge, but then to make videos like this and to talk to us about how the contest was going, and then even to show up today. We actually have 5 judges here with us today. We have Akiba, we have Pete Doctor, we have Crystal Gordon, we have Catherine Scott, and we have Ben Krasna. Whew. I had to look over for some advice there. Sorry about that. So let's have a big round of applause for our judges who are here today. And we love to delay, and we love to make the intensity go up a little bit more, but I think it's actually time to start revealing who the winners are.
So presenting the 5th place award is Akiba. Akiba, Akiba is an MIT research affiliate. He's got Freak Labs Wireless. He's an amazing breakdancer, and I could probably say some other stuff too.
Hi everyone, I'm Akiba. I'm honored to be one of the 2016 Hackaday Prize judges. I will not delay any further. I'm going to try and open this envelope. See. Aha. The 5th place winner was a finalist in 2 categories, anything goes and automation. I was one of the judges for this project, and I thought it was amazing. A lot of people are used to stepper motors in their lives. They run our CNC machines, they run our 3D printers, and they're cheap. When people say servos, they think about hobby servos, like the little ones that you use to drive RC cars, steering, or things like that. But actually, there's a class of motors called industrial servos, which are amazing, and they're expensive. So industrial servos, they're very high torque, very high speed, and low power. And they're also hundreds of dollars. So they're out of the price range of most hobbyists or people that are just interested in designing something that that you can actually sell for less than like $30,000. So for the 5th place on the 2016 Hackaday Prize award, the prize goes to Mechaduino by Joseph Church at Tropical Labs. Is he in the house? So Mechaduino created an adapter board to convert a servo to convert a standard stepper motor, which is very cheap, like on the order of $10 or $20, to a servo motor, which is expensive, on the order of $300 to $1,000, or probably a couple $1,000s. It'll probably open up a new servos to a new class of hobbyists. Okay, and that's it. So
thank you.
Congratulations.
Thank you.
Congratulations.
Thank you.
Do you have anything to say?
Go out towards the middle so that the cameras can
This is incredible. Thank you so much, Hackaday. Thank you to everyone in the Hackaday IO community that gave us feedback and encouraged us. Thanks to everyone who made this possible. Thanks to our manufacturer, our Kickstarter backers. I must be forgetting someone, but thanks everyone. This is incredible.
I'm going to turn it over to Mike.
All right. We're going to go ahead and announce welcome to the stage one more judge. So thank you very much. Congratulations.
Thank you.
The next Hackaday Prize judge is a roboticist and computer vision engineer. She plies her trade in the space realm at Planet Labs. Please welcome Catherine Scott to announce the 4th place winner of the Hackaday Prize.
Oh, where did they hide the giant oversized checks? Okay, I gotta open this up.
All right, I love this project. So the fourth place winner was a finalist for the first category, which is design your own concept, and they kept working on their project up until the very, very end. This is one of the best uses of ferrofluid anyone has ever seen, and it's extremely accurate, which is highly important in sensors. These guys were able to bolt this thing to a table and actually detect the changes in the moon cycle, which is phenomenal. So please congratulate your fourth place winner, the new high accuracy tilt sensor by Aaron Molnar. There's a video?
I think there's a video, yeah.
It's their acceptance video.
All right, so we let Aaron know ahead of time, and he filmed this video.
Hi, I'm Aaron Molnar from Hungary, and this is my acceptance speech for the 2016 Hackaday Prize. So I entered the prize with the project called a new high accuracy tilt sensor, in which I developed a new tilt measurement sensor, which also can be measured, used to measure acceleration. I've got two functioning models or arrangements so far, a linear FCDT and a toroidal FCDT. I entered to the prize because I wanted to discover Hackaday a little bit more. I wanted to get into the Hackaday community, and I wanted to be part of this awesome hacking revolution. I'm really thankful for the prize. It's my 18th birthday coming in November, and it's the best birthday present I can ever get. Thank you, Hackaday.
Oh, you're gonna, okay. Yeah. Okay.
We're gonna dance next.
Presenting the third place award is Ben Krasnow. Ben has a really cool YouTube channel called Applied Science, and he's an engineer, hardware engineer at Verily.
Thanks very much. All right, third place. This was a project that really resonated with me. I don't know if you caught my talk today, you know that I'm really interested in making prototyping really easy and fast, especially if you're into photons or playing with optics. And so please join me in congratulating the creators of the Laser Cut Optics Workbench. And they can't make it to Pasadena, so we're going to watch a quick video.
Thank you so much, Hackaday, for running this event, and also to Microchip, Atmel, DigiKey, and Supplyframe for funding and everything else you did to make this happen. You make all the passion, late nights, and hard work worthwhile. Also, thanks to those people who helped out on the project. Vince, for researching and making the lens demos. Dave, the CAD expert, who took the initial idea and made it workable and who is, and I'm not making this up, building an airplane in his basement. And for donating the acrylic and letting me use their laser, my hackerspace at Make It Labs in sunny New Hampshire. We used to have science toys where you could see the internal workings. You could poke, prod, and make changes to see what effect that had. You could change a resistor, remove a spar, or mix two chemicals just to see what you got. Most learning kits today are snapped together in single function. Learn about lasers by building this simple kit. Legos are fun and all, but the real world doesn't build things by snapping them together. An Erexer set has real nuts and bolts connecting the girders, and a girder can bend and fail if it has too much stress. This was my inspiration for the optics kit. You can move things around, stick things between lenses, and see how it affects the light. We need more science toys like that, and not just for electronics. Toys where kids can take things apart and put them together in different ways just to see what happens. Kids that let you learn by experimenting. Anyway, a big shout out to Hackaday, Microchip, Atmel, DigiKey, and Supplyframe for giving us the tools and incentive to make these projects happen. You guys really rock.
All right.
Thank you, Ben. All right, this next introduction is a pleasure. How often do you get to say that this person is a mix of biologist, neuroscientist, and electronics engineer? She gave an amazing talk earlier today. If you missed it, you're going to watch it in the video. But please welcome to the stage, Dr. Crystal Gordon.
Thanks, Mike. I'm going to be announcing the second place winner. This was a very interesting project. This project was a finalist in the citizen science and automation categories. And this second place winning project takes multiple pictures of a particular object. And what it allows you to do is see this object with various lighting views. This is known as reflectance transformation imaging. And in the end, what you have is this computerized form of this object seen from multiple angles. And I hope, because this is such a well-documented project, I hope that you all will take it upon yourselves to actually try to bring this to life for your own communities, for your own libraries, your own museums, and your own places that keep physical objects that need to be digitized in some sort of way. So with no further delay, I'd like to congratulate Leszek Pavlovich on his second place prize. Congratulations, Leszek.
Thank you. I'm embarrassed to say that my main motivation in entering the Hackaday competition was that I've been promising people for a couple of years that I'd write up the directions to make one of these. And I figured that I needed some kind of incentive. I had hoped I might win one of the sub prizes, but I'm just blown away at getting second place, especially with the competition that I had. I want to thank all the judges for picking me. I'd like to thank all the Hackaday staff who are awesome. Big shout out to Sophie, who helped me when I broke the instructions unit in the on my Hackaday site. I want to thank all the sponsors for the money. It's really nice. And I want to thank all the people out there who've been working to democratize hardware. I mean, without you, this aging, half-assed ex-engineer couldn't have done anything. So thanks very much, and thank you all.
Presenting the first place award is Pete Doctor. Pete is the Director of Engineering at SparkFun Electronics and an analog electronics enthusiast. Also a musician. Come, please welcome to the stage, Pete Doctor.
Thank you. Quite an honor. Oh, I have an envelope? Is that it? You can open it for me. It's cool. Here. Y'all stoked? Yeah? Okay, go. Oh my God. Okay. I was not a judge for this particular project, but when I became aware of it, it was like a really holy crap, somebody actually did this moment, and it was pretty outstanding. It's a robotic platform that is reconfigurable on the fly. It lends itself to search and rescue missions. Ladies and gentlemen, Ditto by Alberto Molina.
Hello, Hackaday. My name is Alberto, and this is my project. His name is Ditto, and it's an open source modular robot. The funny thing about this robot is that it's capable to connect with its friends, creating bigger robots that can act like a one-only robot. They can change its shape, so they can adapt to the needs of the terrain they need to explore. I made this project open source because I really think that these kind of robots are the future, and I wanted people to start studying more on them. But the best part came when, thanks to Hackaday, I started meeting people from all around the world that were also amazed by this kind of technology. And in the end, I cannot describe the feeling of having your work, your project, built in the other part of the world. So that's why I would like to thank Hackaday for the possibility to do this project and for the award that they gave to me. So thank you very much and good luck.
So we'd like to thank the sponsors one more time. Thank you to Microchip, Atmel, Supplyframe, and DigiKey. We'd like to get some pictures with the judges and the Hackaday Prize winners who are here, and some of our sponsors. So can you come up on the stage, please, if you were a part of the Hackaday Prize this year? Yeah. Wow. That was close.
Scoot it in. I think we're going to need a double row. Hackaday Prize. Thank you so much for being with us tonight. We had over 1,000 entries in the Hackaday Prize this year, our most successful prize by any measure. And we encourage you to spread the message far and wide. We always are looking for people to get excited about engineering and science, and this is a great way to do it. It really can change the world. And one last thank you to our sponsors again, Atmel, Microchip, DigiKey, and Supplyframe. That's a wrap for this year. Save the stuff about